All right, so welcome back. Pretty much what I want to do today is just kind of recover just a few topics here. Just right in the beginning, go through a couple vocab terms, just so you guys are aware of it. Draw a couple drawings, get you kind of in that fresh mode. There's one property, I said properties, but there's one property in particular I want to talk about today. Then I want to do a recap of just the semester in general, go through the outline, go through a couple things that you guys should be aware of. So that's what I want to talk about today. Okay. So, is there any questions before we begin? Okay, so we'll get to the outline and stuff later. Right now, I just want to talk about the vocab words we discussed yesterday. So, we were talking about triangles. Let me draw a quick triangle here. Okay, now, triangles, we can put any letters in the corners. It doesn't matter. I'll just put some different variables in the corner. M, N, and O. Now, how do we name it? Let's talk about that. That's something we did last Friday. What do you remember? What's the notation for writing a triangle? You guys remember, please.
You draw a mock triangle, and
okay.
Then you start at any point and go clockwise or counterclockwise.
Yeah. So you're absolutely right. So you draw a little mock triangle when you're naming it. So for instance, if I'm going to name this thing, I would draw the little mock triangle. Start any letter. So pick any letter we want up there. M. Okay. And now you can spin around either clockwise or counterclockwise, any direction, but you have to go in order. So if I'm going to go clockwise, it'd be M, N, O, right? If you started with M, you could have went the other direction, went O, M, O, N. So again, you have to draw that mock picture out front, and then you put the 3 capital letters after it. Now that system works for any different shape, so just be aware of that. I think we've talked about that since day 1 of geometry, just how to name objects, the notational stuff. I'm kind of particular in the way you write that, so just be aware of that. That'll be a big thing in this chapter and the later sections that we're running into. That's notation. Again, if they mark the walls, that means certain walls are the same. So if they put little hash marks here, that means those 2 walls in particular are the same size. The third wall would be different. I don't know what it would be. So whatever the number is. So now why this is important, something you're going to see in this later sections is solving for x. So if they had something like this, if I can write it down. Let's say this is my problem. Let's say it's 7 minus 4x. Say that's my problem. We can go through and we can actually solve that, because you could set these 2 things equal to each other because the walls are the same size. They're congruent to each other. Now, how they would write that in the book, they would write it either like this, like MN wall is congruent to ON, or they would just draw the picture and put little hash marks. So either way, you would actually just set them directly equal to each other and solve for x. That's something you're going to see a lot in these later sections, solve for variables, notice how to look at pictures and kind of set stuff up. Any questions with just the generic triangle stuff before we get to those vocab words that we started on Friday? Perfect. Okay. So now, let's get into the vocab words here. All right. So, major vocab words. So, if we talk about triangles by their side lengths, if I spell that right. There we go. So triangle by its side lengths. What are the words that you remember? How do we name them? What's the classification of triangles? What are the different words we had? Give me one.
Scalene.
Scalene. Okay, scalene. Scalene means every wall is different in size. It doesn't matter which side is bigger, just all 3 walls are different. Another word, please.
Isosceles.
Isosceles. I can spell that right. There we go. There we go. That means 2 walls are the same, no matter, that was like the last picture I drawn where I marked 2 walls. And what's the third one? Starts with an E.
Equilateral.
Equilateral. Okay, so, let's see. Okay, hopefully my speakers are turned on. Turn that up in case I get notification. All right. So again, these are the 3 main words for triangles. What we talked about on Friday was just what do they look like? What are the shapes? What are the weird notational things that they do? So like for instance, for scalene, 3 walls are different length. The book could just leave them all three blank like that. We assume they're scalene, that they're not the same. They could mark them differently, like that. Doesn't matter where the markers go, as long as they're all three are different. So that was just something we talked about on Friday. Is there any questions with scalene? Isosceles, we talked about that one just literally just a little bit ago, where I had a picture. Whoa, where I had a picture where there was some triangle and then two walls are marked the same. That's isosceles. Sorry, isosceles. Two walls are marked the same, and then the last one is equilateral, and that was like this one. So, where all three walls are marked. Okay, you're going to see those a lot. Remember, something I hinted at on Friday last week, the sections as we go through Chapter 4 here, because again, this unit we're in, Unit 5, mixes Chapter 4 and Chapter 8 together. So that's what I'm mixing. The first couple sections of Chapter 4, they really talk about the maiden types. So like today is just generic stuff. Like talk about all the different words, throw in maybe one property or two, and then the last thing is, do we know like how to look at a picture and give it two names every single time? That's the big thing about this section. The later sections, they pick up these specific words, and then we talk about I think it's the third section, talks about just isosceles only. And they just give us a couple of properties that we have to go through. There's a couple of theorems that go with isosceles triangles. And then the later section is equilateral. And then they move on to Chapter 8, and they talk about angles then. So angles are still a big part of this, but those are really apparent when we get those later sections in Chapter 8. So, all right, questions with the side lengths, though? Perfect. Okay. All right, next, we're going to talk about a triangle by its angle measure. Not able measure. There we go. That's weird. All right. What are the three words we can call a triangle by its angle measure? There's technically a fourth, but what's one of them? Obtuse. Okay, that is definitely one of them. Okay, obtuse. Another one?
Right.
A right triangle? Yeah. Let's see if I can go back. Right triangle? And acute. There we go. There's the last one. Now, I said there's a fourth, and technically there is a fourth. The fourth word that we really didn't discuss a lot is equiangular. That's where equiangular, where all the angles are the same. That was a word we didn't really talk about last Friday. That is a word we talked about when we were back in Chapter 1.6, Unit 2, way back in late September. But these are the words. Again, acute. That's where a triangle, any triangle that we have, all the angles are less than 90. So no matter what your angles are, every single one's less than 90. They can all be different. I don't really care what they are. But the angle measures in the corners. That's something that you're going to want to have. So something that we're going to have in this section, we're going to have to use your protractors, the thing I handed out beginning of the year. You're going to want one of these because we're going to be measuring triangles. You'll see that possibly as early as tomorrow, where we look at pictures and we put these on them. So be aware of that. So if you have it, it's great. If you don't, you might want to go find it. Maybe it's in your book. I use mine as a bookmark usually. All right, a right triangle. That's where your triangle has at least one angle that's a right, and only one. Now I said at least. There's only one on a two-dimensional picture, but when we go to three-dimensional, you could have more than one. That's non-Euclidean geometry. But again, one angle is a right angle. The other two are acute. And they could be different. They could be the same. It could be any number, but they have to be smaller than 90. The other two have to in a two-dimensional system. And then obtuse, I think that was the first word we had. One angle is larger than 90. And that's, again, in a two-dimensional system. Euclidean geometry. Okay, equiangular, all the angles are the same. So, whatever the measures are. Okay, questions with any of the vocab from Friday? Now, remember, when you look at a picture of a triangle, any picture, so any of these three or any of the ones I've shown you previously, every triangle has two names to it, two classifications. You have to give them one of these words, so acute, right, obtuse, could be equiangular, but that's if you measured them. But you have to give them one of those, and then you have to give them one of these three, scalene, isosceles, equilateral. So every triangle has two words. So be aware of that. So that'll be one of the test questions you're going to see. It'll be one where I give you a couple triangles right off the bat. You have to tell me the name, classify it. You'll have to use your protractor to measure the angles. I'll give you a ruler to measure the walls. That's something that you'll need to do. That's probably one of the first things we're going to be looking at possibly as early as tomorrow. So we'll see. I got to see what the sections bring. I think this first section is just about angles, I think. So, all right, questions though. All right, one property I want to talk about today. Just one. Okay, there's one. The interior angle of a triangle. So this is one of our theorems. I think it's theorem 4.1, I'm pretty sure. Yeah, theorem 4.1. So here we go. I'm just going to write it up here. In fact, I wonder if I can just type it. I wonder if this would be easier. Might look better. All right, so theorem 4.1. So it's our first theorem. If I would spell it right, there we go. So first theorem of chapter 4. So again, how they name them. The first number that you see on a theorem is the chapter you're in. Then the number that comes after the decimal is what theorem number you're actually on. So we're on the first theorem of chapter 4. But again, it's called the sum of the interior angles. So yeah, the sum of the interior angles of any triangle is 180 degrees. That'll be my degree symbol. So it didn't matter to the classification of triangle. Every triangle adds up to be 180. We did an activity at the beginning of the year when we were in Unit 2. It was in September, where I gave you a piece of paper. Everyone had a different triangle in here. We ripped the corners off of it. So again, I'll just kind of draw a mock picture of what I'm talking about here. So I gave you, everyone in the room received kind of some random triangle, some random cutout, if you remember it. Then what we did is we cut down like the parts of it. So we ripped off a couple of the angles on it. So imagine those came off. And I had you number the corners. So like call that 1, call this 2, call this 3. And we tore off 2 of the angles, and what we did is we turned them around. So we turn, that angle around, and we put them over here. So let's say this was angle number 1. I just moved it to here. And then angle number 2, we put it over here. There was angle number 2. And we turned them, we pushed the vertices together. We kind of spun them around. Pushed so that the actual vertices actually met at one single dot. Then what I had you do is I had you push the walls so that the walls were right next to each other like this. They're adjacent to each other. And when that happened, every single time it made a straight line. And what do straight lines have for an angle?
90.
Not 90, but 180, right? Straight angles are 180. So that was something we talked about. That was a linear pair. It was supplementary. It was some of the vocab words we used in the beginning of the year. But it works on every triangle. It doesn't matter the type. Doesn't matter the shape. Every single time you can push them together. That process we did was just a visual aid to help you with this theorem. It's actually just like a visual proof of it. Now what we're going to talk about is how they actually did it without tearing paper, right? Tearing paper is one thing. You see it here. You can. We did that physical copy where you actually held on to it. But how do you know that it's going to work every time? Well, that relies on the stuff we did in the last semester test. So, in fact, I'm going to draw it right here. So we're going to look at kind of a mock proof of this thing. So let's look at the proof, other than this visual aid. Okay, so here's how it works. So, I'm going to draw my triangle again. Okay, same triangle. It's supposed to be the same. Just ignore my terrible artistic talent. And so what they do is that they start with numbering the angles. So 1, 2, and 3, right? 1, 2, and 3. Right? I don't care what the angles are. It doesn't matter the measures. Doesn't matter. And what they do is they draw a line passing through the vertex at the top. Any line. So I could draw a line that passes through that vertex through here. That was one of our theorems we had in the previous unit. That was unit 4 for us, that through any point you can draw one line through it. It can be perfectly parallel. We even did the construction how to draw parallel lines. We just copy angles. But I can draw a line that goes through there, and I can tilt that line in such a way that it will be perfectly parallel. I can make this line perfectly parallel to the bottom. Do you agree that I can do that? Like, that is possible. I can draw that. So you can tilt it in such a way. Now, when that happens, do you see that we have two parallel lines? We have the top line and we have that bottom line. And now, and this one I want you to draw your attention to, what do we call these two angles right here? What do we call those two angles that I have marked in blue? In fact, I'm going to shade them in here. What do we call these angles? There's a name for it.
Interior, but it's not same side, alternate.
Alternate interior, yeah. So these are called alternate interior angles. So I'm going to mark that down here. These are called alternate interior. What do we know about alternate interior angles?
They're the same.
Yeah, they're the same, right? They're the same. So I could transfer angle number 3. So this is angle number 3, whatever that was, whatever that measurement was, I can transfer that to here, right? Alternate interior have the same number. Now again, why they're alternate interior? They're squeezed between the parallel lines. There is one transversal that's cutting through the parallel lines, and so they're on alternating sides. I can do that also for angle number 1. So angle number 1, I can transfer this angle right here to here because of alternate interior. I'll put double marks because that could be a different angle, right? So angle number 1 can transfer up to here because of alternate interior again. And now you can see that angle 1, 2, and 3 are all touching the same vertex. They make a straight line, because I said this was a line passing through that vertex, and it does make 180. You can actually see it. It's actually a visual. This is actually the proof of what you're seeing here, just not tearing paper. But it's using alternate interiors to make it work. So kind of a cool proof when you actually see like the stuff we did in the last chapter actually being applied. So alternate interior, you know, we can do it by corresponding if I've transferred stuff. So kind of cool system. So, all right, questions with this first theorem in this chapter, this unit we're in. Okay, that's all the notes I have today. What I want to do for this next part here is review the outline that we did at the beginning of the year. So I'm gonna stop my recording here, and then I'm just gonna show you the outline. This is something we did at the beginning of the year, so I might even copy that video on my website just so I don't have to record it again. So, all right, so